And thank you for joining us. This is Orbit Basic Training, Part E, where you add a Power Supply Interface Module, or PSIM. So now, after you have built most of your Orbit stack, including selecting Solartron sensors, perhaps selecting some modules to connect to third-party sensors, as well as your interface, the last thing you need to do is power it. By that, you basically add a module like this, typically with a power pack, and place it on the end of the stack like so. We offer power supply interface modules, which we also call PSIMs, with AC and DC power inputs. These typically power up to 31 sensors, and we have versions that power both probes and lasers. In addition, we also have something relatively new, a PSIM Lite, that powers a small stack from the power of a USB port. So one quick thing to review is that Orbit actually powers sensors of different voltages. So for example, our standard gauging probe requires just 5 volts of DC. A module also requires just 5 volts of DC, but a laser actually requires 24 volts of DC. And how these different types of voltages are run is that actually one pin on the RS-45 connection runs 5 volts for probes. Another pin runs the 5 volts for the modules. And then a third pin can actually run 24 volts for lasers if you are using that on the Orbit stack. It should be noted too that some interface modules can actually power a portion of an Orbit stack. So for example, a USB interface module that can actually draw power from the 5 volts that are coming out of a USB port and power up to 4 probes and modules. Then our protocol interface module, well, that connects directly to a 24 volt DC source, or you can also power it with a power pack and plug that into any type of AC plug. And that will power up to 10 probes or 8 lasers. So with configurations like this, again, a USB, you can just stack up to 4 probes and modules on it. And then with the PIM, you can power up to 10 probes or 8 sensors. So here's an example of a USB interface module powering a small Orbit stack. This is what we've been using for demonstrations. Then here's an example of a protocol interface module powering an Orbit stack of block gauges and flexures. The PIM is mounted in the back. But with most Orbit applications, you will need some form of a power supply interface module. Our standard PSIMs are these. Our most common one is an AC PSIM, and so this is something that will connect to some type of AC power input, 100 volt to 240 volts AC input. And with these, we can provide a plug if you are going to plug into a wall, such as for a UK plug, USA, European Union, or a China plug. So for these, the supply frequency is 50 to 60 hertz, and this powers up to 31 probes and modules, except lasers. Then we also have what's called a DC PSIM, and this, of course, connects to any type of DC power source, 10 to 30 volts, and then this will also power up to 31 probes and modules, except lasers. So when you're putting together an Orbit stack, you, of course, have your interface module, and we're going to use, in this example, interface modules that require a PSIM no matter what. So with an RS-232, the Ethernet interface, or, of course, the wireless Bluetooth, you are not drawing power from the connection. So here, of course, you take your interface module, stack as many probes as you need, and then place your power supply interface module at the end. Now, a power supply interface module, or PSIM, will power up to 31 modules. But then there's a question, what if you have to do more than those? I mean, one of our interface modules, for example, can connect with up to 200 sensors. Well, for that, you just throw another PSIM into the stack and then continue on. So now if we go back to our original Orbit stack, here is putting on an interface module, as well as a power supply interface module. It should be worth noting too that when a PSIM is fully powered, the LED will be lit even when there isn't readings being taken. So now for the USB interface, again, this can power some modules on its own. So if you are using a USB interface module and you're going to power more than 4 modules and probes, all you do is then add a PSIM and then stack onward like so. The same goes for the PIM interface. Again, this can power up to 10 probes or 8 lasers. If you are doing more than that, add a PSIM and then just continue to add to your stack. So now what about lasers? And again, those run on 24 volts. Now for that, we actually have specialized power supply interface modules. So for this, we have what's called an AC PSIM /24/5. So what this power supply interface module does is that it will provide 5 volts along the 2 pins that power probes and the modules, but then it also provides a source of 24 volts along that 3rd pin we mentioned for powering the lasers. So this again, an AC PSIM /24/5. Again, you just draw from 140 volts to 240 volts AC, same supply frequency, powers up to 31 probes and modules, and can power up to 20 lasers. Now this doesn't mean that you can power 31 probes and then 20 lasers. That would be over 50 sensors. There's actually a limitation to that, and to determine how much your power supply will cover, we do have a PSIM calculator, which I will talk about in a second. And in addition, we have a DC PSIM /24/5. And again, you draw from a DC power source of 10 to 30 volts, powers up to 31 probes and modules, or powers up to 20 lasers. So here's a sample configuration. Again, you have an interface module and an AC or DC PSIM /24/5. So here's an application of 2 lasers and 2 probes being powered by one of those specialized PSIMs. Now we also have what we call a special AC PSIM /24. So this is a lower cost power supply, again, powered by 100 to 240 volts AC. Now this does not power modules or probes. So the most ideal application for this is if you have, say, a small application, just 1 or 2 channels, then the USB, can cover it. Now the USB, of course, can't power lasers, but it can power the modules. So what can you do here? You have a USB IM, and then you have the AC PSIM /24, and then you can do an application like this, where you're powering 2 lasers. And again, you can only do up to 4 modules with this. If you have to go more than that, then you have to switch to the regular PSIM /24/5. Now this is our a relatively new power supply interface module that we call the PSIM Lite. So this is a PSIM, and it looks just like our USB interface module, but what this PSIM does is that it is powered by a USB port from a charger or a computer, a charger like what you see right there. Now this will power up to 5 probes and modules. It is not able to power lasers, but this is a lower cost PSIM for smaller applications. Now to separate from a USB interface module, there are like little red clips at the ends of the cable, both by the module and then up by the connector. So here's an example configuration for a PSIM Lite. Let's say you're using an Ethernet interface module to do your connection. That of course draws no power, but what if you have a very small application to do? For this, you can just use the PSIM Lite. Again, this is a lower cost power supply interface module. Plug that into a USB port, and then you can power, like what you see here, up to 4 probes and the module. And then the PSIM Lite with the USB interface module, with this, of course, the USB IM can power up to 4. And then with the PSIM Lite, now you can do up to 9 probes and modules. This could actually cover quite a great deal of applications, because most Solartron applications we see are typically in the 4 to 10 sensor range. So now here's an orbit stack with a USB interface module, along with a PSIM Lite, and both of them are powered by 2 separate USB ports on this laptop computer. Now there are a few recommendations that we have for the PSIM Lite. So for example, if you are running this from a laptop, we recommend that you turn off the power saver mode on that laptop, because sometimes what happens is the laptop will reduce the power output coming out of the USB ports. In addition, we also know that out there can be USB hubs where perhaps you can plug one USB plug into a port and then have like kind of a multiplexer type setup. This will not work well with this type of orbit configuration where you have both a USB IM as well as a PSIM Lite, because you're just drawing from one power source. So do not plug it into a USB hub or splitter. Now there's a few other questions in regards to the PSIM that we occasionally get. Like for example, can you spread out orbit modules like what you see there? Because sometimes the probes and the modules themselves could be far apart for a particular application. For that, yes, you can. Because Orbit operates over RS-485, you can actually just have RS-485 cables in between each particular module. And this you can have up to 20-meter cables. But it should be noted that additional cables do draw more power. Another thing worth noting too is that third-party modules draw more power than a standard digital probe. So for example, a digital probe draws 58 milliamps, but a wireless connection module actually draws up to 100 milliamps. So for this, you'll want to use an Orbit 3 network power calculator. Now we are going to jump ahead a little bit here, but what I wanted to show is the location of the Orbit 3 network power calculator. So this is the Orbit 3 suite. This is what comes with the Orbit 3 software drivers that you download. And again, this will be something we are discussing in section 2 of the training. But I wanted to open it real quick and then show you. Here's the Orbit 3 network power calculator. So we'll just click on this. So when you open the Orbit 3 network power calculator spreadsheet, this is the type of layout you will get here. Up top, you have the controller, which is where you can choose your different interface modules. So for example, we have the USB interface module highlighted. Controller requires PSIM. It says no. But if I switch it to the new Ethan 2.0, controller requires PSIM, yes. Then down here is all the different modules that Solartron offers. DP is of course the digital probe. So let's say we have a package that requires 30 digital probes, perhaps 20 AGMs, and then even some analog interface modules. So we'll say 4 analog interface modules, and then 1 wireless connection module. This next column here shows how much current load is per module, and now here is the total current required. So now if you scroll down, it'll say you will require 3 power supply interface modules. And then at the bottom, we were discussing cables and cable lengths. This is where if you go to different cable lengths, this could also affect the power draw as well. Again, this is located on the Orbit suite. Now for readouts, such as the SI1000, the SI3500, or the SI5500, most of those do not require a power supply interface module. These are actually supplied with an AC power supply package, and the power drawn from there is more than enough to power an Orbit stack. Again, the SI5500, that can power up to 32 modules as well as interface with up to 32 modules. So that pretty much concludes the training. So just to kind of review, Orbit is just an incredibly modular, versatile package where you can connect any number of Solartron sensors up to 200. You can output to a PLC or a PC, as well as connect to third-party sensors. So just to kind of review, we had a quick overview in terms of the Orbit network, and then we went into the details of it, talking about the Orbit module and building an Orbit stack. That included mounting and accessories, the inline plugs and the indicator lamps. Then we talked about choosing an interface module, and that went through the basic Orbit operation, as well as read modes and network speeds. We also talked about third-party sensors modules, and then finished it off with the power supply interface modules, or PSIMs. So the next training sections will be section 2, connecting Orbit to software, and that will talk about the Orbit library, as well as updating modules and programming examples. Section 3 is connecting to a protocol interface module, or PIM. And then section 4 will be connecting to Solartron wireless products. And again, all training is available online through the Solartron YouTube channel. You can also go to just solartronmetrology.com for a link to that channel.